In section 4.11, we're going to start looking at cycloalkanes and talk a little bit about the bond angles and what the shapes of cycloalkanes look like. So if you remember, sp3 hybrid orbitals are typically 109.5 degrees. If we have bond angles that are required to be something different, they're going to cause angle strain. An angle strain is an increase in energy when tetrahedral bonds are different from 109.5. So let's start by looking at cyclopropane. So in cyclopropane, we have what's basically an equilateral triangle. In any triangle, all three bond angles combine to add up to 180. So you have 180 degrees inside a triangle. So if you divide that by 3, what you get are bonds that are each 60 degrees. So there's really large strain in cyclopropanes. Okay, the bonds want to be 109.5, and they're forced to be on the order of 60 degrees. So those are high energy. If you go to Cyclo Butane, so now this is a square, so every angle in here is 90 degrees. And again, there's a lot of strain here because we've gone from 109.5, which they want to be, to 90 degrees. There's 19.5 degrees difference between what the hybrids want to be and what's possible in cyclobutane. If I look at cyclopentane, all of the bond angles here are 108 degrees, and there's very little angle strain. So because of that, cyclopentanes are really common in nature. Because there's almost no angle strain. So then let's look at cyclohexane. In cyclohexane, all of the bond angles are 120 degrees. So you would probably guess that there's kind of quite a bit of angle strain here. And what you'll find out is that they're even more common in nature than the 5-membered rings. But that doesn't seem to make sense, because you would think there's some angle strain here, and then what happens is if you analyze this molecule, you'll find out there's actually no angle strain in cyclohexanes. So the question is, why not? Well, there's an assumption that we're making in drawing all of these, and the assumption that we're making is that they all have to be flat. And that's not true. The rings don't have to stay flat. And because they don't have to be flat, cyclohexanes can bend out of the plane in ways that get rid of all of the angle strain. Now, you can't do that in a cyclopropane because the 3 points in the cyclopropane define the plane. But in cyclohexanes, you can do that. In cyclopentanes, you don't really need to because there already is no angle strain.